This is Sub10 Systems TV. I'm Brian Dolby. I'm talking to our CTO, Mark Stevens. Mark, let's start by explaining what millimetre wave technology actually is.
The term millimetre wave refers to radio frequencies above 30 gigahertz. These have a wavelength of 10 millimetres, hence the Sub10 name, Sub10 millimetres.
And why is it so different, the technology that's out there at the moment?
Mobile applications today are requiring more and more throughput, more and more bandwidth. To get bandwidth out of a point-to-point link, you need to use wide channels, so you need a lot of spectrum. The millimetre wave bands currently have a lot of spectrum available. The bands that are traditionally used for this for backhauling between 6 and 38 gigahertz are very, very congested, and in the future there will be new bands released above the current 80 gigs E-band that will become available for even higher throughput applications in the future.
Are there environments that this is particularly suited to?
Yes, it's particularly suited for street level deployments where you've got a lot of radio links in very close proximity. The short wavelength means that we can use very high gain antennas with very narrow beam widths. These reduce the interference between links, allowing us to pack a lot into a very, very small area.
So this is going to help hard-pressed operators with all their bandwidth crunch demands, I presume?
Absolutely, yes. I mean, we're developing links at a gigabit per second. A year ago, the small cell operators were looking at putting 100 megabits per second links between their small cells, and they're now all asking for a gigabit. So they're really looking to the future to really getting that throughput where it's actually required, down at the street level, down at the person sitting in the coffee shop in London, so he can view the news, download his videos, and those type of applications.
And also more major good news for these hard-pressed operators. I think you've also managed to get some major cost savings.
We have. Traditionally, these frequencies would use a technology called gallium arsenide. This is extremely expensive. We've actually moved to silicon germanium radio transceiver chips. We've also deployed a very low-cost DSP architecture that allows us to really reduce the cost so that the mobile operator's overall business case actually works.
Brilliant. Well, thanks for talking to us, and let's hope those operators come calling soon.
Okay, thank you very much, Brian.